In HyperChem, it's important to understand the coordinate systems. When you create a molecule by drawing, in this case we'll draw N2H4, the molecule is generally the coordinates that you create are relatively random, and we really don't care what those coordinates are very often. Sometimes we do, but in general the coordinates can be anything you like, and when we do a calculation on this molecule we get the same energy, same results, no matter what the coordinates happen to be, as long as the relative coordinates are the same, which they are. But the coordinates consist of two sets of coordinates. There's the coordinates of the actual molecule, the molecular coordinates, and when you select atoms, it tells you these on the status line. These are the molecular coordinates of the atoms in a molecular coordinate system. But there's also the coordinates of the viewer, you yourself who are looking at this molecule. And when you rotate in the normal way with the left mouse button dragging around like this, what we're changing are not the coordinates of the atoms in the molecular coordinate system, but all we're doing is moving the viewer yourself. That is, you move left to right, up or down, and rotate around, and look at the molecule from in front, from behind, and so on, and you move yourself around in the viewer's coordinate system. That's what's moving at the moment. The molecule is not moving, it's staying exactly fixed in the molecular coordinate system, and what's moving is you yourself, the viewer. We can see this, for example, if we take a molecule or take an atom here and translate it. Say we take that particular atom and translate that selected atom to, say, the origin. If we now look at those coordinates, that atom has coordinates 0, 0, 0. Now, when we rotate the molecule around and we look at that atom again, it still has coordinates 0, 0, 0, even though we moved the atom around. Its coordinates in the molecular coordinate system are still 0, 0, 0. So we're moving you yourself, the viewer, and not the molecule. And this is what generally happens with the left button using rotation around the z-axis, translation, and so on. This atom is still, or not that one, but this one is still at the origin and doesn't change. However, there is a way to move the actual molecule. If you select the whole molecule, and when rotate, instead of with the left button, we rotate with the right button. What one is actually doing now is moving the molecule. And if we take a look now at this atom or at this atom, they're no longer in simple coordinates along the y-axis the way they were, but have complicated coordinates because we rotated that molecule in real molecular coordinate space. The viewer stayed just where he was, or you were, or she was, and we rotated the molecule instead of the viewer when it's selected and when you use the right mouse button. But when you use the left mouse button, you're just rotating the viewer only.